nominal T and nominal pi method. So today let us continue the same problem. So in the previous class we have seen nominal T model. Now we are going to solve nominal pi for the same. Okay, this is the problem what we have considered. So if anybody is in the previous class, if anybody is absent, try to note down this example. Determine the efficiency and efficiency and regulation of a three-phase 100 kilometers 50 hz transmission line delivering 20 megawatts at power factor of zero point 0.8 lagging and 66 kV to a balanced load. The conductors are of copper, each having resistance 0.1 ohm per kilometer and 1.5 outside diameter, spaced equilaterally 2 meters between centers. Neglecting ligands and using nominality and nominal pi model. So we have to find out the efficiency and regulation. So first step we have, so from the given problem, we have calculated the resistance for the entire length, similarly inductance and also the capacitance over the 100 kilometers line. Okay, these are the three parameters. Shunt parameters are capacitance and series parameters are inductance and resistance. Next we have calculated capacitance, and the nominal T model means the total resistance. Series elements are divided into two halves, R by 2, similarly XL by 2. So now those two are equally divided into two halves, and at the center of the transmission line the capacitance is added. So the shunt element is capacitance is connected. So for this, the first we have calculated the receiving end voltage. First we have calculated receiving end voltage based on the power delivered, and receiving end voltage is known, power at this point, power output is known. Using these parameters, first step we have calculated IR. Once we obtain that IR, we can find out the total impedance. This is the total impedance. So not total impedance, total voltage drop across this impedance. Current multiplied with impedance gives voltage drop. Just by applying Kirchhoff's voltage law, you will get voltage across capacitance. VC is equal to just drop across this impedance plus terminal voltage or VR. So you will get the total voltage across this capacitance. Okay, so once we know this capacitance voltage value across this capacitance, voltage divided by next capacitive reactance. Okay, so you will get current passing through this. Otherwise, simply current voltage multiplied with susceptance. So you will get current passing through this shunt capacitance. Once we know IC and once we know this IR, algebraic sum of these two gives IS value. IS means sending end current. So just algebraic sum of these two vectors, so you will get sending end current value. Once we get the sending end, we can simply multiply that current with this impedance. You will get voltage drop across this impedance. If the voltage drop across this impedance is known and voltage drop across this is already we have calculated VC. So VC plus voltage drop across this directly gives sending end voltage. Once we get sending end voltage, so keeping the sending end voltage and as constant and the disconnecting the load, that means open circuiting the load, the no load receiving end voltage we have to calculate. So simply by applying the voltage division rule we can find out no load receiving end voltage, that is VR dash, which is nothing but voltage across capacitance. So that is using the formula we can find out no load terminal voltage. Once we get no load terminal voltage and also the known value, so V receiving end voltage, so using these two we can find out regulation. Similarly, once we get the current passing through this resistance and also this resistance, we can find out drop I square R losses in this and similarly I square R losses in this element. So adding these two, multiply with 3, you will get 3 phase losses, power losses. So output power is known, output power by output power plus total losses directly gives efficiency. The same principle, the same method we have derived in the last class. So these are the values using the same. So we have obtained this. Okay. So IC value VC is Vs is equal to Vc plus impedance multiplied with current Is, that is drop. So these and all we have calculated using the regulation. No load receiving and voltage is equal to simply applying the voltage division rule. Vs multiplied with this impedance divided by total impedance gives voltage regular VR dash. Once we know VR dash minus VR by VR directly gives regulation. It comes around 17.4. Similarly, efficiency also we have calculated. It is 93.5 efficiency. Now the second half in this. So a small medium transmission line can be modeled by either using nominal T method or nominal pi method. Okay. Now that is nominal pi method, second method. Nominal pi method means we can directly the series elements we can use the series elements as it is, that is resistance plus reactance. The shunt element, that is which is nothing but capacitance, is divided into two halves. So capacitance value is divided into two halves. One half is connected at the sending end and the other half is connected at the receiving end. So if we use the same parameters what we have calculated earlier, so the nominal pi model for a transmission system, it comes in this fashion. Okay. Now come on, anybody tell me the how to follow, how to start the procedure. First step, what we have to calculate. So from this diagram to find out the regulation efficiency of the system. Anybody? Number 201, 19 B8 5 year 0 201. 19 B8 5 year 0 201. Okay, the first step ఏం చేయాలో చెప్పండి అమ్మా. మైక్ ఆఫ్ చేసి మాట్లాడండి, ఆన్ చేసి మాట్లాడండి. ఫస్ట్ టెల్ మీ how to proceed. మైక్ ఆఫ్ ఆన్ చేయండి. 201 కెమెరా ఆన్ చేశారు, మైక్ ఆన్ చేయలే. ఓకే, గుడ్. నౌ the first step. So these are the known values. Output power is known. Okay, terminal voltage is also known. Being calculated first. So from that we can calculate IR. Okay, that is also known. Previously we have calculated I receiving and voltage using P output by root 3 times VL into cos phi. Cos phi value 0.8 power factor that is given. So using that we can find out IR. Okay. చెప్పండి వాయిస్ వినబడుతుంది అది
సార్
ఓకే చెప్పండి నెక్స్ట్ simple application of networks, that means KVL, KCL and also Ohm's law. Next time calculate చేస్తాం. Okay, that is receiving end current. So already we have calculated. Mic off చేయండి. Okay, now in nominal pi it is preferable to take receiving end voltage as reference phasor. So reference phasor means, so anything we can either we can consider voltage as reference or current as reference. Since the load is, if we take voltage as reference, so you will get current value, current at an angle of, so current at an angle of -5. If we take voltage as reference, 0. For the same system, if we take current as reference, so this voltage vector for in case of lagging, so this is phi value. Okay, this is phi value. This is with reference to current, voltage. Here if we take current as reference, 0 degrees, voltage vector, this vector voltage becomes voltage at an angle of +5. Okay, is it clear? So here, that's why in the previous case, in nominal T model, we have considered current as reference. That's why the current value in that case is 218.68 at an angle of 0. Okay, cos 0 plus j sin 0. So sin 0, 0, cos 0 is equal to 1. So directly we can consider it as 218.68. But in this case, while deriving this, we have considered voltage as reference. So current becomes at an angle of -60. Okay, that's why I have taken 0.8 cos 60 minus j sin 60. So sin 60 is 0.6, cos 60 is it comes around 0.8. So that is, so based on cos, it is not 60, cos inverse of 0.8, whatever it may be the value. Okay, is it clear? Okay, so it is not 60, some other value, cos inverse of ఎంతమ్మా వాల్యూ ఎవరన్నా చేశారా, క్యాలిక్యులేట్ చేశారా యాంగిల్ ఎంత? cos 60 కాదు ఇది వాల్యూ, క్యాలిక్యులేట్ చేశారా? cos inverse of 0.8
6.86.
ఎంతమ్మా?
26.86.
26. Okay, very good. Okay. So if we can take voltage as reference, current value is, it is lagging. It comes around 26 point. Okay. Okay. Now the next step we have to calculate charging current or current passing through capacitance, that is IC1. So IC1 is, once we know the voltage at the receiving end, so which is considered as reference, VR value at an angle 0. So that's why J omega into C, that is susceptance value. So J into omega value 50 hertz into capacitance value 2 pi f into C, that is 0.4977 into 10 to the power of minus 6, that we have already calculated capacitance. So using that we can find out. ఎంత వచ్చిందో చెప్తారా? 213 213 18 series 213 ఎంత వచ్చింది వాల్యూ క్యాలిక్యులేట్ చేయండి. 213 18 B8 1A0 213. కెమెరా ఆన్ చేయండి. అన్మ్యూట్ చేశారు, కెమెరా కూడా ఆన్ చేయండి సో దట్ ఐ కెన్ సీ యువర్ ఫేస్. మీ పేరేంటి? 213. ఏంటమ్మా నీ పేరేంటి? మోనిష్ పేరేంటమ్మా? హలో, పేరేంటి? 213. మైక్ ఆన్ చేశారు, కెమెరా ఆన్ చేశారు, గుడ్. మీ పేరు చెప్పండి, నాకు వినపడట్లే. మీరు మాట్లాడుతున్నట్టుంది కానీ నాకు వినపడట్లేదు ఏంటో. నా వాయిస్ మీకు మిగిలిన వాళ్ళకి వినపడుతుందా? హలో హలో, మీ ఫ్రెండ్ మాటలు వినపడుతున్నాయా? ఓకే. సో ఇట్ కమ్స్ అరౌండ్ J 5.95 amperes. Next step is, once we know the receiving end current and also this charging current passing through this capacitance, simply by applying Kirchhoff's current law, incoming currents is equal to outgoing currents. So IL is equal to IR plus IC1, which comes around something. This is IC1 value. IR already what we have already calculated. If we multiply with 0.8, it comes around 174.94 minus J 131.20. So calculate. ఎంత వచ్చిందో నేను అడిగిన వాళ్ళు చెప్పాలి. Number 263, 18 series, 18 B8 1A0 263. So you have to represent in both forms, that is rectangular form and also the polar form. Convert that, whatever may be the value obtained, convert that into polar form. Polar form means r theta. 263. Unmute your mic.
Sir.
Mic camera on చేయండి. అన్మ్యూట్ చేసి కెమెరా ఆన్ చేయండి. 263.
సార్
చేస్తున్నారా?
చేస్తున్నాను సార్.
ఎంత వచ్చింది వాల్యూ? మీ పేరు?
నరసింహ సార్.
Simha. Okay, okay. Solve చేయండి. మైక్ ఆఫ్ చేయండి. ఆఫ్ చేసి ఆన్సర్ చెప్పండి. Okay. So it comes around 174.94 minus J 125.25. Okay. So that is current passing through the transmission line. That is IL. So series elements. Now once we know this current, we can find out the drop. So if we want to find out efficiency, we can directly find out from here itself. Output is known, power output. Power output by power output plus losses. Losses means I L square into 10. Okay, you will get a single phase losses I square R losses that multiplied with 3, you will get the 3 phase losses. Directly add and we can find out efficiency from this. No need to find out the VS value, sending end voltage. For regulation we have to calculate sending end voltage and also the no load receiving end voltage under VS. Okay, keeping VS as constant. So if we want to find out regulation, we have to calculate V sending end. Otherwise, if we want to calculate only the efficiency, simply by using this power output by power output plus losses. Losses you will get just by calculating IL. Okay. Now, sending end voltage is equal to V receiving end voltage plus drop across this impedance. Okay. So VR multiply with drop across this impedance gives VS, sending end voltage. Okay. So VR plus this is VR. So voltage across this is VR. So this is VR at this point. Here it is V terminal voltage, receiving end voltage. So if we calculate, substitute and calculate the sending end value, it becomes 44,249 plus J 4,886 volts. మీకు ఒకవేళ రాకపోతే ఇమీడియట్గా చెప్పండి, ఎందుకంటే నేను కూడా మిస్టేక్స్ ఉండొచ్చు చిన్న చిన్న కాపీ పేస్ట్లో మిస్టేక్స్ ఉండొచ్చు, అందుకని ప్యారలల్గా క్యాలిక్యులేట్ చేయండి. క్యాలిక్యులేట్ చేయడం ఫాస్ట్గా రావాలి. ఓకే. So this is sending end voltage. This portion sending end voltage. Once we know the sending end voltage, so keeping the sending end voltage as constant, magnitude as constant. So magnitude, find out magnitude. So magnitude, it comes around 44.518 kilovolts. Okay. Next step, anybody? ఎవరైనా చెప్తారా? నెక్స్ట్ ఏం చేయాలి? సిఆర్ క్లాస్ సిఆర్ ఉన్నాడా? క్లాస్ రిప్రజెంటేటివ్ సిఆర్. Nineteen series 207, 19 V8 5A0 207, 207. Okay, very good. Next ఏం చేయాలమ్మా? Once we get Vs sending end voltage, next ఏం చేయాలి? చేశారా? ఇక్కడ వరకు చేస్తున్నారా? చేస్తున్నారా? Show me your notes. Show me your notes. 207. Show me your notes. Show me your notes. మీ నోట్స్ చూపించండి. మీరు రాస్తున్నారా లేదా? మీ ఫోన్ దాని మీద పెట్టినా కనబడుతుంది మీరు రాసేదాన్ని. ఓకే ఓకే okay, you can switch off. The next step is finding regulation. So no load, that once we know the full load value, sending end voltage, the next step is the no load receiving end voltage, keeping the sending end as constant. Again, what I am doing is simply application of voltage division rule. Once we know this sending end voltage and this receiving end voltage is open circuited. Open circuited means voltage across these points is Vs. Okay, so when we assume this is Vs, okay, this is Vs. This is Vs. This is Vs. So that means Vs, series elements resistance, inductance and also capacitance. You can again draw like this. So this becomes the receiving end voltage. VC receiving end voltage under no load condition, VR dash. So VR dash, that is simply these three are series elements, that's why VR dash is equal to simply supply voltage multiplied with this impedance across capacitance ZC by total impedance ZC plus Z dash. So this impedance, okay, that is voltage division rule. The same thing what I have obtained, what I have written, so you will get the same value. So after calculating, it comes around 44,762 volts. So calculate చేసి చెప్పండి regulation. Once we know VR dash and VR, both values are known. So regulation, using the regulation formula, we can find out regulation. Anybody tell me the regulation value? So it comes around 17.47%. Okay. If you have calculators, okay, try to solve this one. So here it is 17.47 regulation, and the efficiency is equal to P output by output power plus 3 into I square R. This is IL square here, that is current passing through resistance. So that is IL square R multiplied with 3 phase losses, output power by output power plus losses. We will get efficiency. So in the last class we have calculated efficiency using nominal T model. In this class we have calculated efficiency using nominal pi model. So if we observe the efficiency values in the previous class, what we have calculated is also 93.5. Here it is also 93.5% efficiency. So thereby we can use for a short transmission line, and the operating voltage is in between 20 to 100, and the line length is, if it is in between 80 to 160 kilometers, we can use either nominal pi model or nominal T model, and also we can use lumped parameters instead of distributed parameters. Okay, is it clear? Anybody is having doubt regarding calculating efficiency and regulation? చెప్పండి, ఎవరికైనా డౌట్ ఉంటే ఇమీడియట్లీ యూ కెన్ కమ్ అవుట్. ఏ స్టెప్లో అయినా మిస్టేక్ వచ్చింది సార్, నాకు ఇది రావట్లేదు, ఇక్కడ డౌట్ ఉంది, యూ కెన్ కమ్ అవుట్ విత్ దట్ ప్రాబ్లమ్, దట్ doubt. Nobody is having doubts. Means what? Whether you can follow or just sleeping. Okay, noting down the values. So try to solve one more example based on this. Okay. So I have so try to solve this one. Don't copy. Simply write down the problem. A single circuit 50 Hz 3-phase transmission line has the following parameters, that is resistance, inductance and capacitance. Determine the sending end voltage and efficiency. So no need to find out regulation in this case. Simply efficiency of the transmission line is sufficient, and also the sending end voltage using nominal pi and nominal T methods. If the line is 120 kilometers long and delivers 40 megawatts at 132 kV and 0.8 power factor lagging. So this is a medium transmission line. Okay. So even though it is 132 kV, so that is the line length is 120 kilometers long, so we can treat it as a medium transmission. Okay, in some textbooks that is up to 120, 130, and in some textbooks that may be 160 kV. So that is operating voltage may be a little bit more. So whereas if we observe the length of the transmission line, it is less than 160 kilometers. So that we have to treat it as a short transmission, medium transmission. అది చూడకుండా సాల్వ్ చేయాలి. ఒక ఎగ్జాంపుల్ గా మీరు ఓన్గా సాల్వ్ చేస్తే మన ఎగ్జామ్లో సాల్వ్ చేసుకోవచ్చు, అర్థమైంది అని. First, finding the total resistance of the transmission line. Inductance of the inductive reactance of the transmission line, inductance is given per kilometer. Everything is the parameters. The first from the given data, resistance value per kilometer that is given. So we have multiplied with 120 kilometers. So you will get the total resistance of the transmission line, entire resistance of the transmission line. Similarly, inductance per kilometer that is given 1.3 millihenries. So I have converted into, I have calculated the inductance and inductive reactance for the entire line length. 120 into 2 pi f. That is converted into ohms. Inductive reactance 48.98 ohms. Similarly, the capacitance value, it comes around 1.2 microfarads. So why I have calculated that capacitance means that is shunt element. So in nominal pi, we have to divide, we have to make into two halves. One half is connected at the sending end, and the other half is connected at the receiving end. In case of nominal t, the total value is considered at the midpoint of the transmission. So its value is 1.2 microfarads. Next, calculation of the first step, we have to calculate the receiving end current. So receiving end current is equal to receiving end power. So the power is, that is given 40 megawatts. What I have converted into kilowatts, 40 kilowatts power divided by root 3 times VL. VL means 132 kV. That's why that is kilo gets cancelled. So the numerator is converted into kilowatts. Here it is kilovolts. Kilo gets cancelled. You will get the total value 218.7. If we consider current as reference, this is 218.7 at an angle 0. If we take voltage as reference, this becomes cos inverse of 0.8 minus cos inverse of 0.8. That we have to remember. So if we take current as reference, this value, current at an angle of 0. If we take voltage as reference, this becomes lagging load. Current always lag behind voltage by an angle theta. So in this case, the theta is cos inverse of 0.8. Okay, because it is lagging minus cos inverse of 0.8. Okay. So now the receiving and line to neutral voltage, that is 132 into 132 kV divided by root 3. This is phase voltage, line to neutral voltage. It comes around 76.2 kV. ఎవరైనా క్యాలిక్యులేట్ చేస్తున్నారమ్మా? ఎవరైనా క్యాలిక్యులేట్ చేస్తున్నారా, సింపుల్ గా ఎక్కించుకుంటున్నారా? చెప్పండి, ఆన్సర్ చెప్పండి ఎవరైనా. మీరు క్యాలిక్యులేట్ చేస్తున్నారంటే నెక్స్ట్ స్టెప్కి వెళ్తాను, లేకపోతే వెళ్ళను. సింపుల్గా ఎక్కించుకుంటున్నాం సార్ అంటే నో నీడ్ టు స్పీక్ ఆల్ దీస్ వర్డ్స్. ఏం చెప్పక్కర్లేదు, అలా ఎక్కించుకోవచ్చు. మీకు సాల్వ్ చేస్తాను అంటే చెప్పిన అర్థం ఉంటుంది. ఎయిటీన్ సిరీస్ 222.
Yes, sir.
సాల్వ్ చేస్తున్నారా? సాల్వ్ చేస్తే ఆన్సర్స్ ఎందుకు చెప్పట్లేదు? నేను ఇక్కడ అడుగుతున్నాను కదా, ఎవరైనా సాల్వ్ చేస్తున్నారా ఏంటి అని అడుగుతుంటే ఎవరు కూడా ఒక్కళ్ళు కూడా మాట్లాడలేదు. ఏంటి రీజన్?
సాల్వ్ చేస్తున్నాం.
అర్థమవుతుందా?
అర్థమవుతుంది సార్.
ఓకే, థ్యాంక్ యూ. సో నెక్స్ట్ స్టెప్ ఏం చేయాలి?
నెక్స్ట్ ఎఫిషియన్సీ ఫైండ్ అవుట్ చేయాలి సార్, నామినల్
నెక్స్ట్ స్టెప్ ఏం చేయాలి? వన్స్ వీ గెట్ రిసీవింగ్ అండ్ కరెంట్ అండ్ రిసీవింగ్ అండ్ వోల్టేజ్, ఫస్ట్ నామినల్ పై కన్సిడర్ చేసుకుంటే ఏం క్యాలిక్యులేట్ చేయాలి?
IC1 ఫైండ్ అవుట్ చేయాలి.
Very good. Okay. So next, now if we consider nominal pi, switch off this and make. If we consider nominal pi, so the voltage at the receiving end is known. Okay, and the current at the receiving end is also known. So the same voltage appears across this. This is V receiving end voltage. That is known value. I receiving end current. That is also known value. The same voltage appears across this capacitance. Okay, we can find out current passing through this capacitance, which is IC1. So IC1 is equal to, so taking receiving end voltage as reference, V as reference, V at an angle of 0, receiving end voltage as reference, current becomes I receiving and current is equal to I at an angle of -5. Okay, that's why I have considered 0.8 minus J 0.6. Either we can remember, we can write from the basics, otherwise we can remember the formula, what we have derived. Okay, so IC is equal to charging current is equal to IC1 is equal to J omega J 314 into, this is capacitance value, half of the total capacitance multiplied with, so this is the voltage V receiving end voltage. This value is at an angle 0. So once we get that IC1, apply Kirchhoff's current law at this junction. So Kirchhoff's current law is incoming currents is equal to outgoing currents. So incoming currents are IL, incoming current, outgoing currents are IC1 plus IR. Okay. Once we know these two currents, we can find out IL. Simply from this, no need to calculate. This is IL. No need to calculate V sending end voltage. What is the need of sending end voltage? Calculating sending end voltage here. Once we know that, output by output plus losses, directly we can use this. 3 into current, that is I square R into I square R. R value is 24. So simply we can find out efficiency. No need to calculate this sending end voltage. So if we want to find out regulation, we have to calculate this sending end voltage. Otherwise, directly from the given data, simply calculating efficiency is that. కానీ ఇక్కడ ఏం అడిగాడు? సెండింగ్ అండ్ వోల్టేజ్ క్యాలిక్యులేట్ చేయమని అడిగాడు ప్రాబ్లంలో. ఎఫిషియన్సీ ఒక్కటే అడిగితే, so no need to calculate this sending end voltage. Otherwise, we have to calculate sending end voltage. So here, what is the sending end voltage? So simply using sending end voltage means sending end voltage is equal to sending end voltage is voltage across this, which is nothing but sum of voltage drop across this, that is IL multiplied with impedance, and voltage across this is V terminal voltage or V receiving end voltage. So this drop plus receiving end voltage directly gives sending end voltage. So this is V receiving end voltage. So this is a drop across the impedance, directly gives Vs sending end voltage. No doubt. So these are the values. So if we calculate, it comes around 92.69% efficiency of the medium transmission line if we use nominal pi model. మీరు రాసుకోవడం అయిపోతే నేను నెక్స్ట్కి వెళ్తాను. చెప్పండి కంప్లీట్ అయిపోతే. ఎవరో ఒకరు రెస్పాన్స్ ఇస్తే నెక్స్ట్ స్లైడ్ మారుస్తాను. Okay, next, nominal T model. In case of nominal T, again we have in this case again the current is taken as reference. In nominal T, current is taken as reference. Simply current at an angle 0, the voltage becomes at an angle of, here the voltage becomes, this is voltage at the receiving end. So current at the receiving end constant, current is taken as reference 0 degrees, voltage becomes plus cos inverse of power factor angle 0.8. So finally you will get the voltage across capacitance is equal to, this is voltage across capacitance VC. VC is equal to drop across this plus V terminal voltage, V drop, that is Vz by 2 value, receiving end voltage, add these two you will get V capacitance. So once we get VC, the voltage across capacitance, we can find out IC, current passing through capacitance. Okay. So once we get that capacitance IC value, so sending end is equal to simply I sending end is equal to incoming currents is equal to outgoing currents. IR is known, IC is known. So we can find out sending end current. Once we know the sending end current, we can find out drop across this drop across this plus voltage across capacitance directly gives sending end voltage. The same way what I have used. Procedure is same. Here in this case 3 times 3 into resistance R by 2 into I sending end current square plus I receiving end current square gives the total losses, power losses, 3-phase power losses. Its value comes around 3.174 megawatts. Percentage efficiency is equal to 40 by output power is 40. 40 divided by 43.174, that is 40 output plus losses 3.174 megawatts. So efficiency comes around 92.6364. So in the nominal T, if we observe, in case of nominal pi model, we have obtained 92.69. But in case of nominal T, it is 92.64. So a slight difference with the second decimal. Okay. So no need to, that is because of assuming lumped parameters. Nominal pi model is more accurate than nominal T. So efficiency in both cases are almost the same. If anybody is having any doubt regarding medium transmission lines or short transmission lines, you can come out. Otherwise, we'll continue the next session. The long transmission lines. The long transmission lines means the length of the transmission line is greater than 160 kilometers. There we have to go for distributed parameters. So if we consider the same lumped parameters in case of long transmission line, a huge error occurs in efficiency, similarly either in regulation. So to avoid that, so we have to use distributed parameters, the same values per unit length we have to consider. That means the resistance is distributed over the entire transmission line. Similarly, the capacitance and also the conductance. Okay. So in the next class, we will see how to model a long transmission line and how to find out the performance of the transmission line, or how to find out the efficiency and regulation in case of a long transmission. Okay. So thank you. So try to solve as many as you can. Okay, try to solve the problems. Otherwise, if you have any doubts, you can send the problems in WhatsApp or through mail. You can contact me at any time. Thank you. ఏమైనా డౌట్స్ ఉంటే అడగండి. Do you have any doubts?